The problem I decided to do is dielectric constant. This problem says a certain substance has a dielectric constant of 2.8 and a dielectric strength of 18 megavolts per meter. If it is used as the dielectric material in a parallel plate capacitor, what minimum area should the plates of the capacitor have to obtain a capacitance of 9 times 10 to the negative 8 farad, and to ensure that the capacitor will be able to withstand a potential difference of 4.1 kilovolts. So the first thing we can do with this is draw a picture of what we're trying to find. So here, so it says we're trying to find the area of parallel plate capacitors. Okay, so right here and right here we have our conductive plates. And then we have the distance right here. And then we're trying to find the area, which is this space right here. So what we can start with is the equation D equals V divided by E. And so V is going to equal our potential difference. And E is going to equal our strength. So the first thing we need to do is convert strength and potential difference. So we have 18 megavolts per meter as our strength, and we need this to be in volts per meter. So it will be 18 times 10 to the 6 volts per meter. And then we have our 4.1 kilovolts. But we need this to be in volts, so that will be 4.1 times 10 to the third volts. And then we have our C. I'm just going to go ahead and list this out. Which are capacitance. So then we have D equals 4.1 times 10 to the third volts divided by 18 times 10 to the 6 volts per meter. And this gives us 2.27 times 10 to the negative 4th meter. The next thing we need to do, since we're trying to find the area, we need to use the formula C. Shoot. That's what I get for using 0.5 lead. C equals our constant, area divided by distance. So what we can do, so our constant here is 8.8 times 10 to the negative 12 farad per meter. And so what we can do is rearrange this equation to find our area. So that'll be A equals CD divided by K constant, which gives us 9 times 10 to the negative 8 F, which is our C, times 2.27 times 10 to the negative 4 meter, which is our D, and divide that by our K, which is given to us up here, which is our constant, the 2.8. 2.8 times 8.8 times 10 to the negative 12 farad per meter. And what happens here is the farads cancel out, and then it's meters squared will be our final answer units. So when you calculate this, you end up getting 8.27 times 10 to the negative 1 meters squared. Box that. It's our final answer. And how we can check this is we can plug it into this equation right here and solve for one of these numbers that we are given. I'm going to use the area that we just found because that is the only thing that makes sense to check. U squared equals, I'm actually going to solve for C for no particular reason. You can actually pick to find any given value that you want and just to see if you get the same number. So we have 2.8 times 8.8 times 10 to the negative 12 farad per meter. And when you multiply this to the other side and divide by 2.27 times 10 to the negative 4, you end up getting what we are given in the original problem, which is C equals 9 times 10 to the negative 8 farad.